this is section 4.2. We're going to learn about the angles to prove the triangle angle sum theorem. I had all the students draw a triangle and cut out the number the angles and then cut out those angles. And then I asked them to put them together. If I can get this to work, would be great. It's kind of hard. Oh, it doesn't want to grab the whole thing again. Where'd it go? Here, I'll try this over again. Oh, there we go. All right, so I'm just going to turn this angle 2, and I'm going to put together angle 1 with it. And so I got to put each of these together, and we're going to find out what the angles add up to. And you guys, the whole class already did this. And then this didn't, well, I'll go ahead and do it like this, because I'm going to see if that slice goes in there. What do you think? Should. See if I can slide it in there. Ooh, I did good. That was a pretty good estimate of turning it. All right. So the point was the three angles of any triangle, no matter the triangle, add up to 180. Okay, so in your ISN, please. The triangle angle sum theorem is on page 3. It says if the measures of two angles of a triangle are known, the measure of the third angle can always be found because of the triangle angle sum theorem. The measure of angle A plus the measure of angle B plus the measure of angle C is 180 degrees. Thank you. The sum of the measures of the interior angles of a triangle is always 180. This is where we put our pieces. So you should have angle 1 with a tear, and that's where I wanted you to, and I don't care what order you have them, but whatever it is, it should have come out to a straight line. I mean, it doesn't matter if they're not in order, okay? And then you taped it on your paper in this spot, I hope. Okay, so we did the proof. Next, find the measure of angle T. The sum of the three angles is 180. We're going to remember that. We've had a lot of 180s this year, haven't we? 180 minus 25 minus 35. That's what I would suspect you would do on your calculator. Some students like to add the two given angles up first, which would be 60, and do 180 minus 60. No matter what we do, the measure of angle T is 120, right? Okay, number 2 says find the missing angle measures. This is in our ISN. First, we would use the first triangle in the upper left-hand corner to find angle 1. So I know that this is a triangle, which means the angles add up to 180. So to find angle 1, I'm going to take 180, subtract 90, and subtract 58. Are we getting, what's that, 22? 32 is what I was thinking it's 32. Is it 32? Okay, 32 degrees for angle 1. So if that's 32, what's angle 2? Why is angle 2 32? Okay, because it's vertical with angle 1. Okay, so we want to remember some things from other units that we've studied. We still have to rely on our knowledge about vertical angles and alternate interior angles, things like that. All right, Chloe, come on. We're going to find angle 3 now. How am I going to find that? Anybody want to tell me what they think I should do? Add 32 and 108. So some people would like to add them first. Okay, 32 plus 108 is 140. And then go 180 minus 140. Or you can just type 180 minus 108 minus 32. And it's going to be 40 degrees, right? Okay. Find the value of x. Now these involve some algebra. These are still angles. Whenever you see the degree sign on there, or they're in the corners. 2x plus 3x plus 4x is equal to 180. We add and get 9x is 180. Divide by 9, and we get x is 20. Then we need to give the measure of each angle. Find the measure of each angle. So we would plug in 2 times 20. One of them is 40 degrees. 3 times 20, 60 degrees is the next one. And the last one, 4 times 20 is 80 degrees. So for the problem, there are 4 answers, and there they are. Number 31, we have x plus 2x plus, the box means 90, equals 180. 3x plus 90 is 180. Next, we would subtract 90 from both sides. And maybe you'll notice at this point that if you have a right triangle, what do you know about the other 2 angles? Those 2 angles are what? What's the word for it? What did these 2 angles add up to? Okay, I'm asking a question about something I want you to observe. Because there's a right angle, what do the other 2 angles add up to? 90. Okay, so those 2 angles are complementary. They have to be complementary angles. Why? Because that's a right triangle. If you have a right triangle, the other 2 angles are complementary. They're going to add up to 90. It just shortens things up for you on some problems. It's not that it's going to be something you can get away with not knowing that and still solve. Because we could divide now by 3 and you get, and all I just wanted to point out that those added up to 90. We get x is 30. And I know some of you already found the angle measures. You have 90 degrees for one. If you have 30 degrees for another, because it's x, and the other one is 2 times 30, which is 60. We have what? Yeah, I don't know what happened when they copied this, because I literally explained to them that they were not to copy the back of, never mind. Anyway, just don't do it twice. You don't need to, clearly. The next thing we do need to discuss is the exterior angle theorem. Okay, what the exterior angle theorem says is that at each vertex of a triangle, the angle formed by one side and an extension of the other side is called an exterior angle of the triangle. For each exterior angle of a triangle, the remote interior angles, what the heck is that? Remote interior are the interior angles that are not adjacent, not next to the exterior angle. So if you see here in this picture, angle 1 is an exterior angle, okay, because it's outside the triangle, right? That's outside the triangle. The interior angles, what would be remote interior angles to angle 1? Remote means they're not next to it. So it would be this angle and this angle, okay? Those 2 are the remote interior angles. So angle B and angle A are remote interior angles for exterior angle DCB, which is the same as angle 1. Okay, so angle A and B. Those are remote interior angles. They are far away. And that's another way to say it is coming up. Exterior angles, like for angle 4, the remote interiors are angle 1 and 2. These are remote interior angles to angle 4. Can't touch this angles, they can't touch each other, or far, far away angles. Now, who sings the song Can't Touch This? It really fits my YouTube thing. Never mind. I didn't even write that, Miss Hoffbauer did. But it fits my Heimer time. Hammer, MC Hammer sings Can't Touch This. Do, 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 do. Sorry, I shouldn't sing it. All right, exterior angles theorem. The measure, I can't believe I just did that on my recording. All right, the measure of angle 1 is equal to the measure of angle A plus the measure of angle B. That's what we need to know. You can take those two angles, add them, and you'll get the one on the exterior. So the measures of an, I don't know why it's plural. The measure of an exterior, I don't get this. This is so worded weird. I have trouble reading things that aren't worded correctly, and my grammar mind goes crazy. The measures of an exterior angles of a triangle, I don't know, is equal to the sum of the measures of the two remote interior angles. I know. The measure of an exterior angle, we should just take off the S's. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. Now it sounds right. Get rid of those S's. I should delete them. Okay, what's it mean? For this diagram, yeah, angle 1 is equal to angle A plus angle B. So you take these two, which are far away. They can't touch angle 1. All right, moving on. I think that we just have a couple of examples, and this was already filled in. Okay, so what do we do with it? To solve the problem, we know that this angle plus this angle, measure of angle 1, is equal to 80 plus 60, which is 140. Example, the second example, these two angles add up to the one outside. So x plus 55 equals 78. And now we could solve for the x angle. So we subtract 55, and we get x is 23 degrees. I did not say anything about can't touch this in my other classes today. All right, the corollary to the angle sum theorem. The angle sum theorem, by the way, is the one that said the three angles of any triangle add up to 180. A corollary to that is the one I mentioned earlier. The acute angles of a right triangle are complementary. Okay, what does complementary mean? They add, in your words, if you have a right triangle, the other two angles add to 90. That's what I think a kid would say, probably. Something like that, right? If you have a right triangle, the other two angles add up to 90. So in this case, since angle C is a right angle, the measure of angle A plus the measure of angle B is 90 degrees. Why does that fit the triangle angle sum theorem? Well, that's what I tried to show you earlier. If the angles add up to 180 and one of them is 90, 180 minus 90 is 90. Okay? That's why it worked. This is for another day. We're done with the ISN. So what we're going to do now is we're going to go to the packet that you picked up on your way in. I guess I should have picked this thing up and brought it down here and shown you. Oh, there's the straight line. Okay, so the sum of the measures of the angles of a triangle is 180. That's the first thing for you to fill in, is your triangle angle sum theorem. Angle A plus angle B plus angle C is 180. The sum of the measures of the interior angles of any triangle is always 180 degrees. Okay, this is on today's paper. Here we go. Time to solve. If they have a 90-degree angle, what do the other two angles add up to? 90. You can always remember, though, that measure of angle 1 plus 62 plus 90 equals 90. So I'm going to, 180, excuse me. Sum of the three angles is 180. Where they got the angle 1 plus 62, the acute angles, add up, they're complementary, was because if you subtract 90 from 180, you get 90. So we can solve for the measure of angle 1 two ways. You can do all the angles add up to 180, or you could do these two add up to 90. Regardless of what you do, if you subtract, and you should be getting that the measure of angle 1 is it 28? Yes? Okay, thank you. What does this mean over here by angle R? Congruent to what? All right, so angle Q and angle R are congruent. So if angle Q is 30, angle R is also 30. And now we can find angle 1. You can add 30 and 30 if you like. The measure of angle S is going to be 180 minus 60, or minus 30 minus 30. I don't care how you choose to do it. It comes out to, the measure of angle S should be 120. Yep. Oops. All right. And number 3. Find the measures of each numbered angle. Now things get a little more complicated. Yes, 120 was the last one. If you have a right angle by the W here, angle VWT would also be 90. Since we have two right triangles, the acute angles add up to 90. So 90 minus 60, and I can find that angle. And it would be 30. So the measure of angle 1 is 30. Now going over here to the other triangle, if that one's 30 and that one's 30, what's angle 2? It's got to be the same as angle V. So it would actually be the measure of angle 2 plus 30 equals 90. So again, it's 60. All right, so our two answers, the measure of angle 2 is 60 and the measure of angle 3 is 30. Okay, number 4, we're going to want to look at triangle MPQ first and find angle 1. So to find angle 1, we'll take 180 and we'll start subtracting 66, and then we'll subtract 58, and we'll find out the measure of angle 1. Will somebody please tell me what that is? How big? 56? Okay. I hear some calculators working. 56 degrees is the measure of angle 1. What's the measure of angle 2? Why is it 56? So if you were doing a proof, you would say angle 2 is 56 because vertical angles are congruent. Hint, hint, they're coming. proofs. More proofs are coming about triangles. Okay, what is angle 3 now? How do we get it? These guys add up to 360 because we got another triangle over here. Well, those angles add up to 360, and we know 2 of them. So calculate away. Measure of angle 3. I'm going to go 180 minus 56 minus 50. Should be 74, right? All right, so we got all of the answers we needed. Moving on. Well, number 5, I see some 30s and 60s in our future. How do I know? Well, I've had a lot of practice. What kind of triangle is this in the corner? It is right. Okay, because there's a right angle there. This one's also right. And the big ginormous triangle is right. So whatever we do, things have to add up properly. Angle 1 is a right triangle, so those add up to 90. So 90 minus 60 is 30. The measure of angle 2, because I have a right triangle in the pink one, the 2 angles here add up to 90, so I go 90 minus 30 and get 60. And then I think, well, if that's 30 and this is 60, do they add up to a right angle? They sure do. All right, find angle 1 in this is number 6. You're just going to take 180, the sum of all the angles, and start subtracting. It's not going to be very big. If I do 180 minus 172, I'm only going to get 8 degrees. Okay, any confusion about how I'm getting my answers? No? Okay. The exterior angle theorem, again, it's just a repeat of what we went over in our ISN. So I've already explained it. You can plug it right in on your notes that angle 1 equals the measure of angle A plus the measure of angle B. A and B are called the remote interior angles. All right, find the measures of each numbered angle. Since the angle 1 is an exterior angle, angle X and Y are the remote interior angles. Then the measure of the exterior angle is the sum of the measure of the remote interior angles. So measure of angle 1 equals 65 plus 50. And that's 115. For number 8, this is an exterior angle 1. These are the remote interiors. They don't touch angle 1. Okay. Oh, I'm sorry. I forgot you had to turn the page of the packet. Okay, so the measure of angle 1 is 25 plus 35, and that is 60. Okay, number 9. Yours does not have degrees on it. Okay, the measure of angle 2 plus 71. Those are the remote interiors. This is an exterior angle. Since the remote interiors add up to give you the exterior, I can set up the equation. The measure of angle 2 plus 71 is 92. Now I can find angle 2 by subtracting 71 from both sides. The measure of angle 2 would be 21 degrees. Now we're back to number 10, which has got the remote interiors. Just add those to get your measure of angle 1. 27 plus 52 is 79 degrees. Okay, 11, 3 is an exterior angle. These two are the remote interiors, so add 43 plus 22. And I got, what, that's 65? Okay. And finally, the measure of angle 4 plus 90 equals 123. This one's your exterior angle. These two are the remote interiors. So I would subtract 90 from 123. And that'll give me the measure of angle 4 is 33 degrees. Okay. Now, oops, you need that? Sorry. Now we're going to have to use a little bit more of our knowledge from the past. We got some parallel lines. I got a Z. What angle can I fill in quick? What are these called? Alternate interiors. We still want to remember that. We got finals coming up next month. Yeah, alternate interior angles. Now, can we go the other way? How about if I do an N? See that? These are equal. So angle 1 is 60. We got a lot of 60-degree angles here. The measure of angle 1 equals 60, and the measure of angle 2 is 60. Okay, now we want to get angle 3. Angle 3 is the sum of these two because it's on the exterior, so it'd be 60 plus 60, which is 120. Now I'll tell you what, let's say you forgot about the exterior angle sum theorem, exterior angle theorem. This angle right here, if this is 60, that's 60. What's this got to be? And what do these have to add up to? Because they form a line, 180. Doesn't it make sense that's 120 now? Okay, so you can use that idea as well. On 14, start with this inner triangle right here. Let's find angle 1. So angle 1, I got to go, all right, 180 minus 35 and 36. Subtract both of those. That's 60, 71. Should be 109. Okay, so angle 1 is 109. Now, I just mentioned a concept that would be helpful in answering a question now. Let's see. Let's find angle 3. Here's your hint. Why? These form what? Gotta remember the vocab. They make a line, so they are a linear pair. And a linear pair, by the supplements theorem, add to 180. Okay, reminder of some of our vocab. All right, so if I know that's 109, this also is an exterior angle. It should have been 35 plus 36 anyway. So 71 degrees. Okay, now let's find angle 2, because if that's 71, this is 71. Now, this is not the only way to get these answers, but I feel like it's probably the easiest. What's left for angle 2 if you look at the triangle at the top there? So we're going to have to do 180 minus 80 and minus 71. It's not going to be too big. Oh, 29. Measure of angle 2 would be 180 minus 80 minus 71. Yeah, that's 29. Okay, we had 3 answers, angle 1, angle 2, and angle 3. All right, one more here. These two are, this is an exterior angle. These two are remote interior angles. So these added, 2x plus 95, will equal the exterior angle 145. That's the way to do that problem, at least, but it's not the only way to do it. And then solve the algebra. What is that, 50? And then divide both sides by 2. Should be getting x is 25. I'm going to just set up a couple more before we go. These two, x plus x equals 58 because those are remote interiors and this one's an exterior. You can finish that off. And 17, x plus 73 equals 3x minus 9 is your setup. Because those are remote interiors, that's an exterior angle. One last one. It says that the wheelchair ramp, one measure of one angle and is 8 times the measure of the other. So if I put x degrees here, this would be 8x. And this would be 90. You don't automatically have 2 minutes to pack. Hold on. One's x, the other's 8 times as big. So x plus 8x plus 90 equals 180. Or you could remember that those two add up to 90. All right, then you find the measure of the angles. All right, that's enough for now. Work out the problems in the packet, and we'll be able to answer questions later.